Hello, we're starting chapter 10 today, and as you can see from the title, it's about exponential functions. And way back at the beginning of the year in chapter 1, we actually talked about exponential functions and sort of the patterns that we see. You also have talked about exponential functions in Algebra 1, and you've probably worked with them in biology as well. So today, together in this video as well as on your own with your groups, you're going to do sort of the three things that are listed. You're going to construct an exponential function, which really just means we're going to write an equation from a sequence. You're going to classify whether it's exponential growth or decay, so whether your population is growing or decreasing. And then you're just going to be able to compare tables, graphs, and equations of exponential functions and figure out, again, growth, decay, if the equation matches. If it doesn't match, create an equation, create a graph, or create a table. So we're just going to start with the first bullet point in this video, which is writing really an equation from a sequence. So again, back in chapter 1, you looked at just tables of numbers. And so here you have 4 tables of numbers, and you notice that, again, the first row is just 1 through 6 and then 10. And the directions say write an explicit formula for the geometric sequence. Then use the equation to determine the 10th term. Round your answer to the nearest thousandth if necessary. So again, when you look at this, we are going to be writing equations. That's our first step. When you look at the second row, again, if you think of your first row as your x values, and if you think of your second row as your y values or your output, you notice that your y values are changing, and they're getting, in this case, getting very, very large very, very quickly. And they already found the 10th term for us. And the question is, how did they do that? So in this particular sequence, we noticed first that obviously the numbers are growing, so we know this would be growth. And we also should notice that how do you go from 5 to 15? Well, you could add 10, but if you add 10 to 15, you don't get to 45. And so in chapter 1, we noticed that when you went from one term to the next term and you were multiplying, in this case, multiplying by 3, that was how we figured out that it was considered an exponential, equation. So that's what we're going to do next. We're going to write an equation for this particular sequence. And hopefully my pen works. So in this particular sequence, we notice that we're multiplying by 3. The other key piece is to know where do you start. And we always start, in this case, with the number 5. So if you're going to write an equation, I'm just going to start with using y equals. So y equals. You start with your first term, 5. What did you do to 5? You multiplied it by 3. So multiply by 3. But then to get to the next term, you multiplied by 3, and you multiplied by 3, and then you multiplied by 3, and you multiplied by 3. So how do they figure out the 10th term? Well, this relates to what we were just studying last chapter, which was all about exponents. So exponential functions are related to exponents. Here, if I multiply 5 by 3 one time, I got 15. If I multiply 5 by 3 2 times, I would get 45. If I multiply 5 by 3 3 times, I get to 135. If I multiply 5 by 3 4 times, I get here. If I multiply by 3 5 times, I get here. But notice that was helping me find the 6th term. If I multiply 5 by 3 once, twice, 3, 4, 5 times, I get to the 6th term. So if I'm going to do the 10th term, I must have multiplied 5 by 3 9 times. And so when we write that equation, because it's not 10, it's 9, we actually write the exponent as x minus 1. Oh, sorry, my pen's being kind of funny. X minus 1. And this would be my explicit formula, meaning if I wanted to find the 10th term, I would plug in 10 for x. 10 minus 1 is 9. If I have 3 to the 9th power, that's like multiplying by 3 9 times, and then I multiply it by my first term. So we have exponential because we're multiplying. It's growth, obviously, because we're getting bigger. And the equation that I'm writing is the first number you start with, what did you multiply by, and in this case it's x minus 1 because it's 1 less than the term number. So let's look at number 2. Number 2, we recognize that our numbers are decreasing, so that would be exponential decay. And we recognize that if we're decreasing, this is just being cut in half. Again, we want to think of exponential functions as using a multiplication equation. So we have y equals, what did we start with? 200. We multiply 200 by a half. And you could write that as a decimal or as a fraction. As a half. And then let's think. So from 200 to get to 100, I would multiply by half once. To get to 50, that would be multiplying by half twice. To get to 25, I'd have to be multiplying 3 times, and so forth. Oops, this should be at 12.5. And again, it turns out that my exponent, because I'm multiplying, is going to be x minus 1. Now to find the 10th term, I plug in 10 for x, so I get 10 minus 1, that's 9, a half to the 9th power times 200. When you plug that into your calculator, again, you shouldn't do that in your head, you actually get scientific notation, and it says round to the nearest thousandth. You actually get 3.9, sorry, my pen is being really funny, 90 tenths, hundredths, thousandths, but really it's not the thousandths because this is in scientific notation, times 10 to the negative 10th. So we get a very, very, very small number because it's a negative exponent here, but that's my 10th term. So that's kind of the purpose of this lesson. Now these next two get a little bit more difficult. Again, how do you go from 1 to 1.25? Well, you recognize that it's growth. And you might need to use your calculator. Well, how do you go from 1 to 1.25? So you'd say, well, what can I multiply 1 by? Well, I can multiply by 1.25. And then you check. If I take 1.25 and I multiply that by 1.25, do I get the next number? And I do. So my equation is y equals first term 1. I multiplied 1 by 1.25. And now you should start to see a pattern forming. I did that twice to get to the third term, 3 times to get to the fourth. So it's always going to be x, the number of terms, minus 1. The last one, you recognize that it's decreasing. How do you go from 1 to 0.8? Well, you multiply by 0.8. So it's going to be y equals first term times 0.8. And then, again, the pattern that we started to notice is that it's x minus 1. Now, I assume that you could plug in 10 in here and find those last two terms, but I'm not going to do that. But that's kind of the first sort of learning objective or multiple learning objectives of this unit. So again, just kind of classifying them one more time. we just did the equation writing. We also talked about growth and decay. The other thing that you just kind of want to mention when you're looking at growth and decay is, what if you don't have the table? How can you tell based on these equations that it's growth or decay? Well, you should notice that if what you're multiplying by is above 1, like 3 or 1.25, those two were growth. If what you're multiplying by is less than 1, not negative, but less than 1, then you have decay. So from here you can open up your textbooks and start working on the problem that is on page 740. Thanks.